What's up, good data friends? It's Yanis here and welcome to my channel. Now please note that this video is actually step 5 of the path towards learning Python for beginners in data science and data analytics. And more specifically, in this video we're going to cover MatPlotLib library, how to create lines using Numpy and Pandas, how to create combo plots, plots using for loops, histograms, and scatter plots. We're going to try to keep this tutorial short because Seaborn is actually the library you're going to be using the most as a data scientist or a data analyst. However, because Seaborn is actually built on MatPlotLib, it's worth understanding how MatPlotLib works because you're going to be using a combination of both, but mostly the Seaborn library. And as always, I'm going to have the whole notebook with the code and the raw data we're going to use for this video in my GitHub page. You can follow the link in the video description and you can download these files and practice with me as we go through the video. And before we start this video, let me just say that if you're passionate with data analytics and data science, then please click the like button, subscribe to my channel, and enable notifications for my future videos. Right, starting from where we left it in the last tutorial, what is MatPlotLib? MatPlotLib is a two-dimensional Python plotting library which is similar to MATLAB. Maybe you have used MATLAB in your university degree. We use MatPlotLib to visualize the data, identify trends, and also identify outliers. MatPlotLib is compatible with both Numpy and Pandas for plotting. Numpy and Pandas are the first two videos we have done in this Python series. Right, going back, here are the libraries we are going to use for this tutorial. We're going to use the operating system, Numpy, Pandas, and MatPlotLib. So we click run. And then the first thing we want to do is to create an array so we can plot it and see how MatPlotLib works. So the first step we do here, if I add a new cell, is that we create this new NumPy array. It's numbers from 1 to 5, so 1, 2, 3, 4, 5. And then in order to plot it, all we have to do is type in plt.plot, and then into the brackets we pass the array. And if we remove this plot.show, you can see sometimes it shows, but later on, when we keep adding things like titles and legends and tigers, then we're going to need to have this plt.show down here. So I always have this plt.show because it's best practice. We can then change these numbers. So we can do this 10. So you can see it changes. We can do this, 56. You can see we change our plot. The next thing we have is when we want to create two arrays. So it's exactly the same thing as above here. We create the array and then we plot it. But down here we have two arrays. So now we have a second array called b equals and then the new array. Then we need to add plt.plot our a, plt.plot our b, and plt.show. And you can see that we see both of these two arrays in the same graph. So if we change this quickly, you can see it changes. And if we change this again to 7 maybe, you can see it changes. The next thing we have now is when we start adding titles, legends, and tigers. So now we have three arrays. So you can see first array, second array, and third array. The next thing we have is that we increase the size by saying plt.figure, and then we set the size to 15 and then 10. I think 15 is the horizontal axis and 10 is the height. So if I show you how this works, so if I run this above here, quickly, you can see it increases the size of my plot. The next thing we have is that when we type in plt.plot a, we don't close the brackets like we've done here. We add a comma and we add more things. And the things I'm adding here is that I can change the color. So I set the color to green. I can change the line style to this dash and dot, which is basically this green line, the dash and the dots we see. And then I can also add a label, and this label is going to be the rent of 2024. And the label is actually going to show later on when we plot the legend. So if I don't plot the legend, I'm not going to see this label. That's why I need both of them together. The next thing we have for the second array is plt.plot b. We set the line width now, so we can change how big it is, so the width to 5 dot, and also I add the label as the average rent. For my third array, I type in plt.plot c. I set the color to red, which is this red. I set the line style to 2 dashes, and I set the label to rent 2023. As you can see, rent 2023. Then we can add a title. So as you can see, plt.title. Then I need to pass the title, comma. Then I need the font size. So how big is this title going to be? So we can change this. If we put this to 2, you can see it's tiny. We can't even see it. So if we set it back to 20 as it was, now it's bigger. So it's the size of the fonts. And then the font weight, we want to set it to bold. Next, we want to plot the legend, and then the location of the legend is upper left, which is where we have most of the space. So if we have free space on top left, we add it on top left, otherwise middle or bottom or on the right side. Then we need to set the font size to 15, so we can actually change this to 10, a bit smaller. No, maybe 15 was fine. Then we need to plot the tigers, and the tigers are actually our x-axis. So the Jan, Feb, March, April, and May. So you can see if I remove this quickly, you can see we have a number from, it's just random numbers based on our data point. But in order to add our tigers, first we need to set the range, and our range is going to be between 0 and the length of A. The length of A is the number of numbers we have in our A array, which is 1, 2, 3, 4, and 5. So basically what this is doing is that we say that we want a range between 0 and 5. So it's 0, 1, 2, 3, 4, 5. So it's 0, 1, 2, 3, 4. Actually, probably starts counting from 1. So 1, 2, 3, 4, 5. And then we need to set the values we want to see. So the 5 values we want to see. So January, February, March, April, May. I can actually change this to whatever, and we're going to have the labels down here. Sorry, the tigers. Then we need to plot the X labels, which is basically the title of our X axis, which is months, which you see months. Then we need to plot the Y label, which is the rent in dollars, which is the rent in dollars. And then we type in plt.show, and we see this plot over here. Now, I have shown you how to create this manually because later on now, we're going to use the Pandas. So we're going to use actual data, which is this data. And as arrays, we're going to be using these columns. So these columns are going to become our arrays over here. And then we can adjust their colors, their legends, their titles, their tickers, and everything we have just shown. Right, so the first thing we want to do is to load our raw data. So we type in pd.readcsv, and then we copy the path of our file, and then the name of our file, and then .csv. You can actually download this file from my GitHub page. And then we visualize our data. So this file is actually the same data as we have used in our previous tutorial, which was about the joins. Then if we run this quickly, we can see we have our raw data over here. We can also print the shape, so we can see how many columns and rows we have. So dot shape, you can see we have 205 rows and 26 columns. I'm going to move this here and then type in enter, so we can actually see our data. And the first thing we want to do is to create a simple line graph showing the price of the cars. So this data set, by the way, I haven't explained it, but it's just cars, then details about those cars. So things like engine size, the stroke, the ratios, their top speed, and also their price. And let's say we want to create a simple line graph that shows the price of the cars. So it's exactly the same way as we have shown before. However, instead of passing the array over here in the plt.plot, we pass our column. So this is our raw data, and this is our column price. So this price, and this is creating a line graph with the prices of all the cars. So it's plotting all of this array we have over here in Excel. The first thing you see is that we don't have the names of the cars, so we actually need to add the names of these cars. So down here, we need to plot the tickers. So we type in plt.xtickers. First, we need to specify the range, as we've said before, and the range is always going to be from 0 to the length of our array. So, sorry, this is our array, so the number of values we have into this array. And then comma, we need the names of the cars, and I also changed the rotation to 90 because we have lots of cars. So if we visualize this, you can see we have so many cars that the data is not actually visible. So as a data scientist or a data analyst, the next thing you would want to do is to break this data down so you can easily read it. So what I do over here is that I limit the data into only convertible cars. So from my raw data, I want to select everything where the car price equals convertible. And I also want to reset the index because I'm going to plot it. So these convertible cars now, so if I run it quickly over here, you can see it just has 6 rows, and it's because we only want these 6 cars that are convertible. And the convertible is basically specified from the car body, which is over here. You can see all of them are convertibles. The next thing I do is copy and paste exactly the same code as we have from here, but now I apply it only on convertible cars. So you can see here now we only have about how many? 6 cars, and we can see their prices, and we can see that the most expensive car we have in convertible cars is this car over here, which is the Porsche Boxster. Next, we want to repeat the same process now, but we want to cover all the car bodies, not just the convertible cars. So if I do this quickly, so you can see all the car bodies, you can see we have convertible cars, hatchbacks, sedans, wagons, and hardtop. So now I need to create a list. I actually named this convertible car list, but it's actually the car body list. So let me change this quickly. I need to copy this, paste it over here. Let me see, convertible cars. So this is, I'm going to leave it as convertible cars. It's not going to change anything. So now I say for C, which stands for cars, but you can put any letter there, in our car body list. So we're going to start with our first element in the list, which is the convertible cars. Then I need to set my raw data. Actually, I'm going to change this so it makes more sense. So I'm going to save into this data all of the data that the car body equals C, and this C, the first loop is going to be these convertible cars, the second time it loops is going to be hatchbacks, the third time it loops is going to be sedans. Then I want to copy and paste exactly the same code as we have above here, down here. So I set the size, I plot the price. I'm actually going to change this now to data, as you can see, because I'm changing the data. Then I need to change this to data, change this to data, and then I should be fine. So if I run this quickly, just to show you what this does, is that let's print, also print the C, so you see how the category works. So the first time we loop, we plot the convertible cars. So this is exactly the same. Let's make the figure size smaller so we can see it. So the first time we loop it, so let me make this 7, there we go. So the first time we loop, we start with the convertible cars, so convertible. The second time we loop, we're gonna plot the hatchbacks. So if we scroll down here, you can see we have a plot with the hatchbacks. It's actually a lot of them. Then we plot the sedans, and again, you can see it's a lot of them. Maybe I should increase this to 15. No, I think it's the other way around. So let's keep this 8 and then these 15. Yeah, maybe now they are more visible. So these are the sedans, these are the wagons, you can see them, these are the hardtops, and that's it. So now we created a loop that goes through all the car bodies, and then we plot the prices of the cars. Right, moving on, the next thing we want to do is to, let's see, here we have an example, 2 data points on the graph. So maybe we want to plot, what do we plot here? The horsepower and the engine. So the first thing I want to do is, because the horsepower and the engine require aggregation of the data, the first thing I need to do is to aggregate the data. And here I'm just aggregating the data by averaging the price, averaging the engine size, averaging the horsepower, and then averaging the wheelbase. And this summary data one, if I copy it quickly and I run it above here, you can see we have an aggregated data frame now that has the averages for car body and drive wheel. What I do here is that I also create another column, and the name of this column is car body and drive wheel, which is this one over here, which is basically concatenating the car body and the drive wheel into one column. If you don't know how to do these group bys and the aggregations, we've explained them in the previous tutorials, which was the Pandas tutorial. So I suggest watching that if you don't know how to create summary tables. Because as a data scientist or a data analyst, a lot of the times before you plot the data, you're going to need to aggregate the data first. This is why I do this now. I aggregate the data and then I repeat the same process. So I set the figure size, then I plot my horsepower, I add the label as horsepower and then the light width to 5 dot. I repeat the same process for the engine size. Then I plot my triggers, and in these triggers, again, we need to repeat the same process with the range as we have explained, but the label now is going to be this new column we created over here, because we need to indicate both the car body and the drive wheel. Rotation to 90, I plot my title, and then I plot my legend upper right, which is over here. Then I plot my X labels, which is this car body over here, and then plt.show so we can view the plot. So as you can see here, there is a very high correlation between the engine size and the horsepower. So this is one of the findings you're going to investigate as a data analyst or a data scientist. Right, moving on, we're going to show the combo stack bars. So a combo stack bar is this visual you see over here. So it's one bar on top of the other, so they are stacked. So the first thing I do is that I set the figure size, then I plot my first bar, plt.bar. Then we need to specify the range, and as we said, the range is always going to be from 0 to the length of our array. In our case, is the engine size and the horsepower. They have the same lengths, these two arrays. Then comma, then our column name, which is the engine size. Then the label, which is the engine size, which is this green. Then the width, and then the color, which is our green, as you see over here. Then we need to repeat the same process for our second bar. So as you can see, it's the red one. Then we can also add a line. So here I have also added the wheelbase. So this is this line over here. Let's change the color to black maybe, so it's more visible. Color equals and then black. So let's see, you can see it's this one over here, but I didn't see much of a relationship, so we didn't really need it. Then we need to plot our X tickers. So it's exactly the same process as we have explained before. These are our X tickers. Then we need to plot our title over here. Then we need to plot our legend, which is this one, and then the X label title, which is this one over here, and then plt.show. So the reason we've done this now is because maybe as a data scientist or a data analyst, you want to investigate whether the engine size is related with the horsepower. So for example, these cars that they have lots of green at the top, these categories, not cars, they have big engine sizes, but the horsepower is not matching it. Versus these two over here especially, so the hatchback 4-wheel drive and also the hatchback rear-wheel drive, they have big engine sizes, however the horsepower is up there with the engine size. So maybe these cars are more efficient, so it's something we need to investigate further. Right, the next thing I want to show now is pretty much the same data as above here. Now we want to switch it into a horizontal bar graph as we see over here, and we also want to have it as a combo bar, so next to each other versus having them stacked, so on top of each other. So to do this, we need to select the two columns we need, so engine size and horsepower. Add dot plot, and then on kind we need to add the bar H, so horizontal, set the colors, which is green and red, and also set the figure size. And the rest are exactly the same as before, so it's exactly the same from here, but instead of adding plt.x triggers, now we need to add plt.y triggers, because it's not on the x-axis down here, it's actually on the y-axis over here. Same case with the label. Now it's not an x label, now it's a y label. So the reason we need to know how to do this is because, let's say we stayed with this visual for the hatchback rear-wheel drive, we are not able to see the engine size. So we don't know how much bigger the horsepower is. However, now we can actually visualize it is this one, because it's the only example we have that the horsepower has higher average than the engine size. So maybe this is like a very good category to buy a car. I don't know anything about cars. I'm just investigating this as a data scientist or a data analyst. Right, moving on, the next plot we're going to show are the histograms. So to create this histogram, we need to type in plt.figureSize, so we set the size. Then we need to select the column we want to create this histogram for, and then we need to set the number of bins. So I usually use anything between 7 to 10, but you can see now we've broke it down into 7 bins. Let's see if we do 4, for example. You can see it's not as nice. If we do maybe 15, again, you can see maybe it's too much. So I usually do between 7 and 10, but it's up to you which one you want to have. Then we plot the title, the X label, and the Y label. So we've shown this a lot of times. And what we can see is that the majority of our cars fall into this category over here, which means that they are between $5,000 and $10,000, and the rest of the cars fall into these other categories. So this is how you would investigate the distribution of price as a data analyst or a data scientist. You need to keep this in mind later on when we are going to run your predictions, that anyway, the majority of the cars are between these prices over here. Right, moving on, the same way we have investigated the histogram for price, maybe we want to investigate it for more variables like engine size, horsepower, stroke, wheelbase, and peak RPM. To do this now, we need to create a for loop. So it's exactly the same way as we've done it before. So I create these variables over here. I set the name of the columns I want to loop for. And then I say for v-in variables, and then I literally copy this code over here, paste it down here, but I change the name of the column from our raw data. So instead of having raw data and then price over here hard-coded, I set it to v. So what this is going to do is that it's going to start from price, then it's going to plot the engine size, then it's going to plot the horsepower, the stroke, etc., etc. So now we can investigate this by scrolling. So you can see this is the price. We have created this above. Then we have the engine size. As you can see, it's again skewed on the left side, which means that the majority of the cars' engine sizes are between 50 to 150. Then we have the horsepower, again, is skewed on the left. Then we have the stroke, which is more of a normal distribution. Then we have the wheelbase, which is, again, this one is a bit left skew. And then we have the peak RPM, which is not that normal, but a bit on the left. And that's it. So this is how you can quickly create a lot of histograms to investigate the distribution of your data. Right, moving on, we have the scatter plots. So in order to create a scatter plot, we're gonna need to have the x-axis and we also need to have the y-axis. So we need two variables. So we start by setting the figure size, then we type in plt.scatter, and then we need our x-axis, then we need our y-axis, sorry, the x variable and the y variable. The color is red, and then the marker is this plus sign you see over here. Then we need to plot the title, so this is the title. Then we need to plot the legend, upper left, up here. However, we only have one variable, so we don't really need this legend. It's not going to change anything. Then we need to plot the X label, which is this one, the price, and then the Y label, which is the engine size. So if we run this quickly, we can see the relationship between the price and the engine. Scatter plots are extremely important in data analytics and data science because they show us the relationship between two variables. So what this is telling me is that as we increase the price, the engine size goes up, or vice versa. As the engine size goes up, the price of the car goes up too. So for example, these cars over here, they have high engine size and also high price because they are over here. And these cars over here, they have low engine size and also low price. So with this way, we can investigate the relationship between two variables. But let's say we want to repeat this process for more than one variable. So I need to create this for loop again. I need to set my variables into this variable list, and exactly the same way as we've done it before, we copy the same code. So we copy this code, we paste it over here, but instead of having hard-coded variables over here, I leave price as my one hard-coded variable, and for the y-axis, I set it to v. And this v is going to start from price, engine size, horsepower, stroke, wheelbase, and peak RPM. And then if we run this quickly, we can see the relationship between price and y. Our y is this price over here, and then it's going to be engine size as we scroll. However, we need to plot it so it's visible. So let's do print, print, and then the v, so we know our y. So you can see this is the relationship between price and price, which is not giving us anything. So we can actually remove price because price is actually constant over here. So if we rerun this, we can see this is the relationship between price and engine size. Let's make this a bit smaller so it fits in our page. So let's do 10 and 5 maybe. Let's see. There we go, it's a bit more visible now. So this is the relationship between price and engine size. So again, you can see that as the engine size goes up, price goes up. This is the relationship between price and horsepower. Again, there is a relationship. So as the horsepower goes up, the price goes up. Then here we have the relationship between price and stroke. This is not a very strong relationship because, as you can see, we do have expensive cars that have low strokes and then high strokes. When I say low, I mean 2 or 3 strokes and then 4 strokes. Then we have the relationship between price and wheelbase. There is some relationship here, but it's not that strong. Then we see the relationship between price and peak RPM. Not much of a relationship over here. Right, and the last thing we are going to show now, let's say we want to have a scatter plot that has the relationship between engine size and price. However, we want to break down these cars into their respective car body. So whether they are convertible, sedan, wagons, hardtop, or hatchbacks. Now in Seaborn, there is a much easier way of doing this, but in MatPlotLib, we actually need to write this for loop over here. So the first step you need to do is that you need to group your data by the category you're going to have over here. By the colors, you're going to break it down. So the first thing I do, if I copy this over here and then I create this new cell so you can see it, I group the data by the car body. And then into car body, I have the variables I need. I actually don't need all these variables. All I need is the price and engine size, so we can reduce them. So let's do price over here, and then the engine size, and then we can remove them. So it's easier for you to understand. What did I do? I'm missing something. Let me see. I'm missing the car body, so I shouldn't have removed the car body, which was the first thing I removed. So I actually don't need anything after here. There we go. So this is grouping the data by car body, so you can see all the data is grouped, and the aggregation is set to min by default. And then we need to first create our subplot, because each time you're going to add a new category, you actually need to create a subplot in order to view it. So we type in figure, comma, AX equals plt.subplots, and then the figure size. And then we type into our for loop for car body. So this is going to be the 5 different categories we're going to loop through, comma, car body summary, which is this car body summary here, in the car body summary, because it's from the same data frame, ax.scatter. Then we need our x variable, our y variable, set the marker into this x's you see over here, and then the label is going to be this car body over here, which is going to be these 5 categories we have. The rest is the same as before. We plot the legend, which is here, we plot the title, we plot the X label, and then the Y label, and then if we click run, actually I haven't removed all of these, so let me remove these because we don't need them. There we go, we click run. So now we can see the relationship between the engine size and the price by car body over here. So maybe we have the expensive cars over here, but not really. I can see a good blend between all cars, expensive or not. What I can see is that the green ones, so the hatchbacks, are usually cheaper in price, and also they don't have high engine sizes. By the way, this is a much more complex way of doing it. Later on in the next tutorial, I'm going to show you how to do this in Seaborn, which is much easier. Right, so this is it for this tutorial. I hope you've enjoyed this tutorial and you've gained enough value out of this tutorial. If you feel like you did, then please click the like button, subscribe to my channel, and enable notifications for my future videos. In the next video, we are going to explain Seaborn and how to create all these visuals in Seaborn. Seaborn is actually much easier to use and much nicer. I use Seaborn most of the times. However, you have to understand how MatPlotLib works, because a lot of the time you're going to be using a combination of both. Especially the more customizable stuff, you're going to need to write Seaborn on top of your MatPlotLib code, which I'm going to show you in the next video. Thank you very much for watching this video, and I'm going to see you in the next video.